Good.
Hi.
Sorry for the delay.
All right. So hello everybody. How are we doing? There's so many people here. It's great to see you all. Yeah, so this presentation is going to be a bit of an overview of one of the many threads that form an ongoing collaboration between myself and Lara, who's joining us online and is very much participating in this presentation. Lara is a professor of musicology at the University of Cologne, as Andrea has already said. And our collaboration, I guess, at a very high level is concerned with melodic analysis in Carnatic music. I'm particularly interested in segmentation tasks, so things like node-level transcription or pattern recognition, which of course requires expertise of the music, and that's where kind of Lara comes in. But that's not to say that the relationship is one-directional. The idea is that we create these processes and models, and that they are useful for Lara's musicological research. So there's quite a clear division of roles in our collaboration. My background is in tech. I'm an engineer and I'm a musician, but I'm not, unfortunately, a Carnatic musician. Lara, conversely, has a musicological background, of course, and does indeed have expertise in music, having studied it for many years in South India. And that division of roles is going to be reflected in the format of the presentation as well. So Lara is going to begin and give a bit of an overview of the music and some of her musicological research, and then I'll take over and talk about the analysis that we've built on top of that. So, Lara.
Yes, I'm still here.
You want to take it away?
Yes, that would be great. Thanks so much, Tom. Okay, so, oh, that's interesting. Excellent. First slide. So yes, as many of you will know, Carnatic music is a style of art and devotional music performed in South India. And here is a little example. It's a kruti, a composition called Mayatita Swarupini, performed by the vocalist Pompeu Jayashri. Mayatita Swarupini. And so in order that you can understand the analyses that follow, I'll give an introduction to some major structural features of Carnatic music. So Carnatic music is formed from svaras, which can be thought of as note positions, and these are indicated by syllables, which are known as sargam syllables. Sargam is a form of solmization, such as do, re, mi, fa, sol, la, ti, do, but instead, in Carnatic music, we have sa, re, ga, ma, pa, da, ni. So the gamakas, the ornamentation in Carnatic music, are incredibly important, but they're not normally notated. In most notations, you only have what you can see below here, which is the svaras and the approximate or relative duration and the lyrics. So we have the svaras on the top line and the lyrics below. Here I have a little transcription into staff notation of the same phrase. As you can see, well, staff notation, it has some negatives. It fails to capture a lot of the features of the ornamentation in this style. It doesn't capture the oscillations and the slides that are so important in the style. But it does give some idea of the pitches touched on during the performance of these ornaments, these gamakas. And you can see also here that the majority of svaras are indeed ornamented. And this is audio of the same phrase. Mayatita Swarupini. Mayatita Swarupini. Here I have another example, a different composition. What you can see at the top right here is handwritten notation. It's how my teacher used to give me the compositions, in addition to playing them so that I could pick them up. So yes, here you have the handwritten notation, and below there's the pitch extracted from the audio. I think it is using Pratt in this case. And so what you can see here, hopefully, is the relationship between the notation above and the performance below. So the svaras here are ma, magaga, and here we have the same. And you'll also, when you hear this and see it indeed, you'll be able to see that there are differences in the performances of the same svara. So thinking in particular now of ma, the svara ma performed here and the svara ma performed here. So the first one, a little oscillation, and the second one, a much wider single oscillation. I'll now talk a little bit about the relationship between gamaka and raga. So an important aesthetic goal of Carnatic music is to convey the mood or character of the raga. Ragas are melodic frameworks, and ragas are expressed through their characteristic phrases. And gamakas, the ornamentations, are fundamental to these characteristic phrases. Gamakas in actual performance can be thought of, in fact, as little motifs performed in place of the notated svara. It can also be thought of as different ways to perform the same svara. The gamakas that may be performed on a svara in a given situation depend firstly on the raga. It's constrained by the raga. It also depends on the immediate melodic context, and this is a fact that's well known by musicians, Carnatic musicians, but has also been noted by some musicologists. In fact, you can see this understanding of the way that the swara performance depends on context, even in early treatises. In books of music theory, for example, the Sangita Samayasara of Parshvadeva from the 13th century treatise, his 13th century treatise, it is written when in music a tone moves from its own pitch towards another so that the second sound passes like a shadow over it. This is called a gamaka. So this is a definition of gamaka, and it nicely describes how these ornaments tend to reach across individual swaras, leading to the influence of one being felt on the other. As here's another later perspective on the same phenomenon. So this is from the music theorist Ranga Ramanuja Iyengar. He wrote that the moment a gamaka, an ornament, clothes a swarasthana, that's the swara pitch position, the latter is quickened into life, for the gamaka builds up a relationship with the neighbouring members of the family to the right and to the left. So thinking about this acknowledged dependency on context, I made a contribution to theorizing this in 2016 when I proposed that it could be theorized as coarticulatory. So coarticulation here is defined as the merging or simultaneous articulation that occurs between conceptually distinct units when they're physically produced. To give you a bit more background on this, so the concept of coarticulation actually originates in phonetics. It's been understood for quite some time that the way the production is used to describe the way the production of a phoneme is influenced by surrounding phonemes. And so an example that you can think about here is the t in tulip. So we don't say tulip, we say tulip, and the t already has lip rounding anticipating the u in tulip. So that's a very typical example of coarticulation in speech. This concept of coarticulation has been extended to research on other aspects of human movement, including fingerspelling in American Sign Language and also in piano playing. And finally, it has been applied to music in general in the work of Wolfgang Godoy, and then by me to the structure of Carnatic music performance. And here's a little example from my article from 2016. It illustrates why the two das that you can see at the end of this phrase differ from each other. So what you're actually seeing here in this plot is the movement of the violinist's hand up and down the fingerboard, in fact, seen from above. And so, so you can see how he's producing the svaras through the oscillating hand movement. So we can see that this first da at the end of the phrase is the way it is because it's coming from the ni beforehand, which is higher in pitch. And then the second da is the way it is because it's coming from lower down. It's coming from the previous da. And all of this, as you can see, is performed through an oscillation of the hand and, of course, of pitch. So I'll play that once more so you can try and relate it to the plot. Okay. So, in summary to this section, we can understand that svaras are note length units with theoretical pitch positions. One additional piece of information you'll need is that the flattened or sharpened versions of each svara are typically represented through this scheme that you can see here shown on a keyboard. So we have sa, ri1, ri2, ga2. It's just a way of expressing the semitone, the conceptual semitones, if you like. And in practice, the majority of svaras are performed with gamakas, but not all of them. Gamaka, ornamentation, it performs an integral rather than decorative function in Carnatic music. Their performance is not optional. And also in any given raga, the same swara may be performed in several different ways depending on its immediate melodic context. And here are some examples. These are 4 pitch curves of the swara ni in Raga Bhairavi from an analysis that we made together some time ago. And you can see how different the performances of ni are in each of these cases. So, having presented that background to you on swara performance and also on coarticulation, I'll hand over now to Tom so that he can talk about our analyses on this phenomenon. Thank you.
All right. Is that good? Is that me? That can't be good. Hello?
It could be someone else in the room, maybe.
No, it says I'm muted, but I'm not. Okay, I think I am okay now. You can hear me okay online, Lara? Yes.
I can, yes, yeah.
Great. Well, thanks for the introduction, Lara. It's always great to see you talk about that stuff because we speak so much, but it's always in quite informal settings. So thanks for the great introduction. So I'm actually going to go over some of the things that Lara's already spoken about, and I want to do it again because I want to do it from a bit of an outsider perspective. And when I say outsider, I'm not necessarily speaking about myself. I'm kind of speaking about the models that we're trying to train on this music because those guys are really outsiders. You know, they don't know anything until you show it to them. And if we want to do tasks like segmentation or transcription, then the characteristics that Lara's just introduced can make those tasks particularly difficult. So I'm going to show a few phrases in Carnatic music, and I'm going to do that through pitch curves, which Lara has already kind of introduced, but maybe I'll just make a comment on their ubiquity in Carnatic music analysis, especially in MIR. It's a very common way of representing the melody in Carnatic music, not least of all because it captures this gamaka that Lara has spoken about, gamaka that information that might be lost if we were to convert it into symbolic notation, since there is no canonic form of representing gamaka in symbolic notation. So what we're going to do is listen to this phrase, or a couple of phrases, and then we're going to have a look at the transcriptions of these phrases overlaid, and we're going to talk a bit about why that makes the tasks of transcription difficult. So this is a phrase in Raga Bhairavi. We're going to listen to the audio, and then we'll look at the svaras. No, okay, now it's getting fun. Let's have a look at this.
Are you sharing your screen, Thomas?
Screen? Yes.
Oh.
You mean sound? You can see my screen, I guess. You're muted, Lara.
It's fine, but it's not a problem, Tom.
Okay. So that was a phrase. The important thing I want to show is the svaras overlaid on this. So just to be clear, these aren't automatic transcriptions. These are transcriptions by a Carnatic musician. And already immediately you can see this level of gamaka that's applied to them. And we're going to have a look at one swara in particular, and that's gap. So we have three versions of the same swara here. And as you can see, they're very different, but they're slightly different. They occupy a slightly different pitch space, and they have slightly different ornamentation on. I'm going to come back to this, but I just want to show you one more phrase. Same raga, same performance, same composition, different phrase. Of course. Let's have a look at the svaras. Let's have a look at the ga. So here we see two more variants of ga, and they're very different from each other, and they're very different from the variants we saw before. So what we begin to see, as Lara began with, is that the picture is a bit more complicated than simply this note level classification. So while we do have this category of swara, notes of ga, actually this ga can take many different forms. And we use this term swara form to refer to this. This is not a Carnatic music term. This is a term that we've created to facilitate our research and the communication of it. And you can think of swara forms as this sub-swara class corresponding to the unique note ornamentation unit. So this unique swara gamaka unit. And what you can see here is that this one ga in this one composition has forms which are very widely different from each other. I think only one of them begins on the theoretical pitch position of ga. They occupy almost an entire octave of pitch space. And we want to tell our models to understand this. We want to be able to classify these in the case of transcription. And hopefully you can see that why that might be very difficult. I would probably argue that a professional Carnatic musician would have difficulty classifying all of these as ga if they were to look at these pitch curves in isolation. And because, as Lara said, that's because they don't exist in isolation. They exist within a context. They exist within the wider raga context, which we're not going to speak too much about in this presentation. And they exist within a local context of the phrase. And this is not a revelation for musicians. Musicians know this, either explicitly or, if not implicitly, because it forms an important part of their learning process. And we wanted to investigate these different swara forms that exist in this music. And we did that through a couple of papers that we published last year, a couple of analyses, which we referred to as the swara forms papers. And the objective of these was twofold. One, to identify the unique swara forms that exist in Carnatic music performance, and two, to kind of investigate the relationship that has on melodic context. Okay, so I'm going to give an overview of these papers. The methodology is slightly different, but at a high level, conceptually, they're very similar. So I'm going to give a bit of an overview of how we did that. I'll start with the data. So we have two data sets that we use to fuel this analysis, both from the Comp Music project. The first of which is the Carnatic Varnam data set. That's 28 performances by 5 professional Carnatic vocalists across 7 ragas. And that data set comes with accompanying symbolic notation. It's not fully aligned, so we did have to do some alignment ourselves, which we were able to do. And the result of that, we have very large portions of this performance annotated at the symbolic level. Then we have the Saraga data set, which, as part of these papers, we augmented with some saturated swara annotations from a Carnatic vocalist. So we have some performances from this data set annotated at the swara level, at the note level. Okay. So how do we identify swara forms within this data set? So this is not a particularly exotic methodology here. You'll be familiar with this kind of structure. And between the different analyses, there was some slight differences, but at a very high level, we learned some embedding space on these swara time series, so the time series corresponding to their predominant pitch. And then in the most recent study, we used TS2VEC, so it's a self-supervised model, so we can put our swaras in. It learns this fixed length embedding space where, if it works very well, which it doesn't, then similar swaras are very close in that space, and dissimilar swaras are distant in that space. Okay, and then once we have all of our swaras embedded in that space, we can do clustering in there to identify candidates for swara form. So are there clusters of very close svaras, which are very similar. And we wanted to prioritize finding real candidates for swara forms, so we were very strict in our clustering here, finding these what we call prototypes. Okay, so we used a clustering like HDB scan, where you can exclude certain observations from clustering and they get discarded as noise. So we identify these prototypes, and then finally for the entire data set, we go back over the svaras and classify these svaras to a prototype if the dynamic time walking distance between them and the group is below some threshold. And again, that threshold is very, very strict. And this doesn't work perfectly, actually. So in all of the instances of trying this, we actually have to do a lot of manual pruning afterwards, because these models haven't proved to be very, very good at representing these svaras in this learned space. We're going to come back to that. This manual pruning was done by Lara, and it's quite laborious, thousands of svaras, but we did it, and we created this data set of unique swara forms, so sub-swara classes, which let's use for other analysis. So results of those studies, in the first one, we just did it in Ragabay. I'm showing you here 4 clusters for the swara da. We did it for all svaras, but we won't go over all svaras. And here you see 4 pitch curves corresponding to 4 unique clusters. And what we wanted to do with this study is kind of publish this clustering with a kind of data dictionary explaining from a music theoretical perspective exactly the nature of these individual types. And we did that, and it's available online there across all of the svaras in the 2 performances for Bay Review that we had. Then for ICCCM last year, we extended this analysis to include multiple ragas. This is where the Carnatic Vadnam dataset came in. So we wanted to identify swara forms that exist across ragas here. So here I'm showing 2 clusters for the swara ri. So now we're looking at columns. So this left column is one cluster. So 3 examples from one cluster. The right column is 3 examples from another cluster. And what we see is there are swara forms that exist across multiple ragas. So for example, here we have this version of Ri, which comes up from Sa, goes up to Ga, and then dips down to Ri again. And we noticed that mainly in ragas Mohanam and Sahana, but we noticed it in others such as Kalyani. And you can already begin to see here, qualitatively, this relationship between swara form and context. So for this cluster, every single observation was preceded by Sa, every single one. And 80% of them were succeeded by Ga, irregardless of cluster. Okay, sorry, irregardless of raga. Okay, we have another example here on the right. So this is a version of Ri which comes down from Ma down to Ri. Again, we noticed this in multiple ragas, where we have 3 ragas here in which it exists. And in 80% of observations, this swara form exists within the motif Ma Ri Ga. Okay, so same motif, different ragas, same swara form. So as I say, you can just by looking at the results, you begin to see this dependency on melodic context now, on how certain swaras are performed. But we can go further than that, because we have the annotations, we have the saturated annotations for this data set, we have thousands of them. So we wanted to see whether we could quantify this relationship. So what we did for every swara is we assigned them a contextual token. Okay, so we're going to go through this for the example that I show here for Da. So here we're looking at Da, this version of Da, let's say it's cluster 1. I can't remember if it's cluster 1, but let's say it's in a cluster and it's succeeded by Pa, Ma, Pa, Sa, Ni, etc. And it's succeeded by Ni, Sa, Ri, Ga, Ma, Ga, etc. So we want to annotate this swara with a contextual token. And we do this at 15 levels. So we do it for the preceding context, so the left context. We do it for the succeeding context, for the right context. And then we do it for both sides. And we do that for context length 1 through 5. So the left-hand context with k equals 1 is Pa. So as you can see, it's just 1 to the left. Left-hand context for k equals 2 is Ma, Pa, and P, and so on. Same for the right-hand side. K equals 1, Ni. K equals 2, Ni, Sa. K equals 3, Ni, Sa, Ga. On the both context, we iteratively take from each side. So what we end up with is a set of categorical features. We have one feature corresponding to the cluster that this Da is in, so the swara form, the way of performing this swara. And then we have 15 contextual features characterizing the melodic context in which they're performed. Okay, so when you have data in that form, we can start to look at whether there is any information shared between these 2 sets of features. So, and we do that using mutual information. So what we're saying here is for every combination of cluster group and context feature, of which there are 15, we say, is there any information about the contextual feature that reduces uncertainty about the Svara form group in which it lies? And it's normalized for comparison, so just to maybe build some more intuition if you're not familiar with this metric, a normalized mutual information of 1 means that every DAR cluster has a unique context and that those contexts are consistent within those groups. A normalized mutual information of 0 means that every DAR cluster has a random selection of contexts. Okay, so I'm going to present to you the results for this DAR. We did it for all Svaras, and I've chosen DAR because it's indicative of the results as a whole. So this is what we noticed across all Svaras, this relationship. So here you see the normalized information for the right-hand context in blue, the left-hand context in yellow, and then both sides in green. And what we see is this pattern across all of the Svaras and all of the analysis we've done. So first of all, there is a significant correlation between Svara formed and the context in which it sits. So in the case of least correlation, here we still have an NMI of 0.5. Okay. In general, the left-hand context is slightly more covariant with Svara form group, but in no case does the left or right individually outperform both sides. So the most indicative contextual feature of the Svara form group is looking at the context on both sides. In almost all cases, well, in all cases actually, we noticed that as you increase context size, so well, I've put N here, but before I was using K, but this is context size. As you increase context size, you increase the codependency between context and Svara form group, and that kind of plateaus off after, in this case, 2 more or less, but sometimes 3. After 2 or 3 Svaras, the relationship dies out. So as you get further away from the central Svara, the correlation between the context and the way it's performed dissipates. And we noticed that across multiple performers, ragas, and compositions. Okay. But as I said, you might remember we used it earlier on. I mentioned about these embeddings models for the varas, right? You know, we want and how they're not perfect, and how we actually do a lot of manual pruning. And in the process of doing that manual pruning, we're getting knowledge from Lara and injecting it in the process, and we've got these results for that reason. And we want to go further and ask ourselves, these results, this contextual relationship, can we encode it in our Svara representation models to improve their performance? So that brings us to the kind of the final section of this talk, which is leveraging melodic context. This is a summary of a paper that we published at CMMR late last year. And the objective of this paper was to investigate whether the inclusion of melodic context in a time series classifier, so a Svara time series classifier, improves its performance for our truth data set. Okay. And we did that by presenting a model. This model is quite simple, really. It's actually an adaptation of an existing time series classifier, Deep GRU. But what we've done is added the ability to include these contextual features corresponding to the preceding and succeeding melodic context. So each observation for this model is a Svara that we want to classify. In this case, it's the blue curve, the current sequence here in the middle. That's what we want to classify. But this is accompanied by 2 extra curves. So it's got the preceding sequence. So this is equal to twice the length of the central sequence. That too is informed by this plateau that we saw, that there's less information after 2 or 3 neighbouring Svaras. And then we have the succeeding sequence, which is also equal to twice the length of the central Svara. So we have these 3 curves that characterize the Svara observation that we want to classify. Now, one thing we haven't spoken about, silence is of course also a contextual feature. Phrases almost in many cases by definition begin after a silence or end on a silence. So we want that. It's not a melodic feature, but it is relevant to. It is a relevant contextual feature. So we encode silence as an extra feature in our time series, and hence we have a 2-dimensional time series. So we encode each of these 3 time series separately with stacked GRUs as in the original model, but a lot smaller version than the original model. And then we compute this co-attention on these 3 encodings, with in each case with reference to the hidden state of the central Svara encoder. So we're saying which parts of the contextual time series are relevant to the classification of the central one, basically. We pass that to another GRU layer as in the original model, and we get this final embedding by concatenating these three states. The model is trained and optimized in a supervised fashion based on the classification of Svara in our ground truth dataset. Okay, so does this work? We performed 2 experiments to understand whether including context improves performance or not. One to predict Svara, and another one to predict Svara form. And in both cases, we try the model with the contextual time series included and with the contextual time series not included, basically. And in this case, it reverts back to the original deep GRU model. So we trained this on a ground truth data set of just over 2,000 Svara annotations across 2 compositions in Raga Bay from 2 different performers. We train the model using threefold cross validation and very small hidden layer size, even though we don't have much data. And we augment the training data by balancing class distributions. And the results are modest, but a notable improvement when we include melodic context. So in the case of classifying Svara, we improved the F1 of the classifier by just over 6%, and in the case of Svara form by nearly 8%. Something that's not quite obvious here, the relative uplift in F1 when including context is a lot higher for Svara form, which is perhaps not so much of a surprise given what we've spoken about until now. And that's great because this corroborates musicological and computational studies on this topic before, and explicates this characteristic of the music that is understood by musicians. And just on that last point, I guess I'm going to wrap up on that last point and just kind of frame this within the context of this special interest group, which is computational musicology. And the reason I wanted to do this is because for me it's not like super well defined what is computational musicology, and I'm not going to define it here for you. But I think this is a nice example of a project that's included musicians, musicologists, and engineers, and created something that could potentially be valuable to all of them. So we've got this. So I think it serves as a nice example of how computational musicology could work. So we've got this implicitly understood characteristic. Svaras vary in their performance owing to gamaka. This is learned through Raga phraseology, i.e., there's a dependency on context. Then musicologists come along and they theorize this, as Lara has done with a coarticulation, and then we try and support these theories with computational analysis or quantitative analysis, and then we use the findings of that to incorporate. We incorporate the findings of that into our models to improve their performance. And ideally, these models then could be used for downstream tasks like transcription, pattern finding, music analysis, and hopefully be useful to people who aren't engineers and people who are interested in the music. So with that, I'm going to end, and that's the end of the presentation. Thank you very much for listening. Maybe I'll flick through the references for the video. And that's it. Thank you very much. So I guess we've got some time for questions. If anybody has any questions or comments online as well, very welcome to contribute.
I have a couple of questions. First one, a clarification. Regarding the segmentation, you are assuming that the segmentation is known of
the svaras.
The svaras, right?
The transcription.
Yeah. Okay, so it's based on transcription.
So it's based
just to understand.
Yeah. I mean, there's a whole other conversation to be had that Lara would be best placed to have around on how much of a ground truth it is. But I mean, these transcriptions were done on the composition parts of the performances, so not the improvisational parts, which are accompanied by published notation. It was done by a musician. So
there's a sort of ground truth.
Yeah, exactly. Yeah, definitely. You might the comment I made before about the conversation is you might see slight differences in onset and offset. But yeah, there's a ground truth, and we're operating as a ground truth.
In terms of the examples you're working with, you actually have annotations for the onset.
Exactly. Yeah. Definitely.
So they are
for many performances. Yeah.
Manually, let's say.
And that was a contribution of this first study that presented.
Perfect. That's a clarification. And the other thing is I was curious about this finding of the context that actually, influences this coarticulation concept is super nice. I already knew it from speech, because at some point I was studying speech, and was a concept that was there. So it was super interesting to come here to the MTG, and I got to know that from Thomas that Lara was also applying it to music, and it felt like very intuitive. so thanks for that. But I was curious about, because I'm not aware of how this works actually in speech, apart from the very broad concept that a certain phoneme, of course, may change how this is articulated depending on the context. But do you have any ideas of either on speech, which is something a little bit more like not so close to our application, but other examples of this in music? How long should we typically expect this context to be? Because in this case, it's like two to three. You mentioned like svaras, and it seems that in speech, at least for me, it's like, of course, that the one phoneme at each side for sure affect the articulation of the current, let's say, phoneme. But I'm not sure what happens if there are any studies that actually address that. I mean, if there's something in the context of music that would also be super interesting to compare to this particular case, right?
Mm.
That's what I was curious about this. Yes.
Yeah, I could say something briefly about that. I'm not aware of other studies that have looked at exactly the same sort of thing in music. But talking about the distance, some of the studies on fingerspelling that I mentioned, Jed et al., I think they look at longer-term coarticulation to some extent. So maybe that's one area to look through. And I'm sure it must have been done in speech as well. I just don't have a reference for that to hand.
It's a very interesting question to.
Yeah, I like it very much. I like it very much because, of course, the idea of coarticulation in speech was, well, it's one of the things that made it very hard to identify speech units because they're always changing, and we have exactly the same problem in this musical style. It's one of the things that makes it so hard to identify svaras automatically. So yeah, it's a nice parallel for sure.
Satya, you have a question online?
Hello, can you hear me?
Yes.
Hi, Tom and Lara. Amazing work as usual. I have a general question and a specific technical question. Let me start with the general question. Is that my first intuition after, especially the work in which you compare like two ragas, I think Mohanam and Sahana, I think you compared, and you could find that despite the two ragas being different, you could see the swara forms had some similarities. So my first intuition was, isn't this better solved at scale? For example, if there's an effort goes towards large annotation of multiple ragas, and then what I would think is then applying more powerful models with more data would actually help to sort of find further correlation across different ragas and probably help you with coming up with sort of a general dictionary of swara forms. Maybe I'm thinking, of course, this is very high intensive in terms of effort, but given the results, I can already see it working that way.
Sure.
And
I mean, exactly. That's the problem. We're aware of that. We're aware of that, obviously, but creating such a data set is hugely time consuming, labor intensive, and I don't know, Tom, do you want to say a few words about that?
No, well, I was going to just say that, and maybe also not the best use of time of Carnatic musicians either. No, that's it. Yeah, if we had the data, we'd absolutely do that, as is always the case, these things.
And the second one was, in this case, you're directly working with time series. Have you thought of doing any experiments in terms of like either resolution of time or the thinking of some other alternative representations, just to make it more computationally less intense, I guess?
Yeah, well, one of the nice things about, absolutely, that would be great, because in other work we've done, we've identified that segmentation cues also correspond to acoustic features, like loudness or spectral features. The problem with that is, pitch time series is a very efficient way of representing the melody. They've almost got no noise, assuming you extract the pitch correctly. But once you start looking at, CQT, and it captures many elements at once, and then you're telling the model to learn which parts of that are relevant to the task. And that's fine if you've got a lot of data, which we don't. So yeah, well, I hope that answers your question. But maybe we get more data, maybe we can do it. Yeah.
Thank you.
Yeah.
If you may, because this connects a bit with Satia's questions. Well, first of all, congratulations. I think this collaboration is a beautiful example of computational musicology, because it's where the methodology is allowing to come to new discussions, right, about how to understand the music, and coming up with the concept of Svara form I think is a great contribution already in the work you're doing. So it's really great and really beautiful to work to see how it approaches. So yes, I want to ask related to what Satis was saying. So the input to your model is just the time series, right? Because I was thinking that for the human listener, we have a very important tip for getting this well, which is the sa, right? The tapura information, which tells you at least from the distance to the sa, which Svara could be, right? I'm thinking in Hindustani music, you have a bhairo, you have a re and dha behaving similarly, but of course re is so close to the sa, and dha is far to the sa, that you already have a key which Svara could be. You think that if you input the picture of the sa could help the identification of the Svara, because now you're working just with contour, right?
Well, the thing is that it's implicit in the normalized pitch codes, because they're normalized to the.
So they're normalized. Okay.
So they're measured in cents.
So measured in cents.
We have
so
that information is in there.
Then it's there already. Okay.
Yeah. I mean, for any of the analysis that we do, manually check the tonic, but there are the striking data set, for example, tonic is extracted automatically, and I think that does use the tamper.
Then it's there. It's normalized.
So I mean, you're absolutely right, but we have the tonic. We have the tonic. Yeah, so it's
there already. Yeah. And do you work in tempo? Do you consider tempo could be also influence in the articulation of that? And you have some.
Lara, maybe Lara can say something. She's nodding. She knows more about it than I do.
Yeah, no, explain, Tom. We did that test, no?
No, so absolutely. One, but then, so I mean, lots of the work that Satya's been doing has been around beat and down detection. It's a difficult task in Carnatic music, so if you don't have the beat annotated, then you need to rely on suboptimal methods to extract it. But Satya's making progress with that, so maybe one day we'll have it. In the case of the Varnam data set that I talked about earlier, that comes from beat annotations. That was part of, I can't remember the word now, but it's an MTG contribution, right? And in that case, we aligned. I mentioned that it was a bit difficult. They were semi-annotated. It was a bit difficult to align them, so it was part of the process was aligning this published notation with the beats and section annotations. So yeah, absolutely, yeah.
I thought Rafa was talking about the way that the duration of the Svara affects how it's performed. Which
past MP would be
Which we actually did a test for in one of the papers, no?
Yeah,
Of
absolutely.
course
So
it does. I mean, musicians all know that it does. You can only fit so much ornamentation into
yeah,
specific space in time, but we did do a test for that. Yeah.
we did, yeah, in the papers, in one of the papers that I spoke about. I didn't speak about these parts of the results, but we looked at the relationship between duration and spiral form as well. There is a correlation there, so, which makes sense, as Lara says. If it's a very short spiral, you can't do too much. Very long spirals, so 2 seconds are much more likely to be stable, I'd say, from looking at the data set. So. We've got Shivashri online. Thanks for joining, Shivashri.
Hi, thank you for the nice talk. I just have a question. Could you, will it be possible to enumerate all the transitions between 2 given notes in a particular raga, or any pair of given notes in a particular raga? And if using this method, and if you did do that, it would be a good pedagogical tool, right, to teach raga, which in itself is an abstract form.
You want to say something, Lara?
Yeah, I'm a bit unclear. When you say transitions, are you talking about the Svara forms that we're talking about, or are you talking about how many Saturday?
So if you take, so if you take Bhairavi,
yeah,
and you take any 2 notes, Re to Ga,
yeah,
so there are multiple ways you can go from Re to Ga.
sure, yeah,
like.
Yeah, so now I'm aware. Sorry, what's your question in relation to that?
Would it be possible to computationally enumerate all possible ways to?
Well, that's kind of what we've been doing with that sort of information. We have enumerated the different Svara forms that we could find in our data set, and they relate to what the transitions, because so we have that. So that information is somehow in there. I'm not sure how. I guess if you wanted to use it, I think it's your question, for pedagogical purposes. I don't know. We might have to somehow present it in a slightly different way, but the information is kind of in there already for the data set that we have, which unfortunately is a little bit on the small side. Hopefully we'll do more work on this in the future and get a good number of annotations in, so we can make a more complete job of it. Yeah, thanks for the nice question.
Anything else?
I have a few questions. You mentioned that you did data augmentation for balancing the sort of classes. What kind of augmentation did you use?
So in this study, we did time dilation annotation, so between 10% longer and 10% shorter. You would expect to find differences in time between performances anyway. More recently, we've been looking at other augmentation techniques so looking at pitch, just like shifting in pitch in the y-axis. Not huge, what would be considered errors, but y-axis and x-axis dilation.
And another thing I'm interested in is how do you define a false positive or a false negative in this scenario? What are the metrics that would where would you cross the threshold? A Svara is not this Svara.
Well, that's a very good question, because often, maybe Lara can take this question actually. Did you understand my question, Lara?
I couldn't hear it very well. I can't hear people who are further away from the mic. Could you repeat it?
Yeah, so you're referring to the Svara forms, the initial analysis I presented. We did some manual pruning, and we kind of, to some extent, decided why is this a Svara form and this one isn't? Why does one belong to this group and this one not? How do you decide what is a false Svara form in that case?
Most of the pruning was a result of incorrect pitch extraction, as far as I remember. So a large percentage of the ones that were just, they were false Svara forms because they were clearly a result of incorrect pitch extraction. creating some melodic movement that just doesn't actually exist, in fact, in the audio. So this is one major problem that's still there, unfortunately, in that process. And then yeah, I think mostly if the pitch was correct, it was pretty great, actually, the grouping. Sometimes the other type of pruning that we did was maybe because sometimes it's very subtle, right? Sometimes you can have two, maybe the grouping has gone into two groups. They're very similar, but you can see there is some difference. But it's quite marginal, and then it becomes difficult to decide, is that a different Svara form or is that just a slightly different version of the same Svara form? So this is the sort of thing that I'd like to do some studies and get feedback from Carnatic musicians on, in fact, that level of grouping. So the first problem is getting rid of the false ones because of the bad pitch extraction, but then the rest of it is more a matter of really trying to work with musicians, I think, to see how they would group these in these more subtle situations where there's a small difference. You can see the logic behind what the grouping has found, but some people might consider it the same Svara form. Yeah.
Because in like automatic harmonic analysis, the biggest problem is annotators don't agree on what is like the right
Yeah. Did you hear that, Lara?
Yeah, I'm aware we've also done that and had the same issue, of course. But we can get to some sort of a consensus perhaps on something like this, which is this would be the goal.
Yeah. And just to reiterate what Sir said earlier, I wanted to just ask, using how does normalization work in this context? Because using the tonic as a conditioning information intuitively makes a lot of sense. But how you mentioned that it's normalized according to the tonic and also measuring in sense, how does that alleviate the problem?
Well, because different singers have singing different registers, and when you're using techniques like dynamic time warping, we're basically computing the distance between two curves. So you can have exactly the same curve, but a female singer's curve would be here, and a male singer's curve would be here. So they have a huge distance, but they might be exactly the same. So that's why it's important to normalize for tonic, and even the same singer might have different tonic. It's not just male or female. So it's important. I'm working with multiple performances to do that normalization. Other than that, I don't think we did any other normalization in the stuff that I presented here. I don't think so. Yeah. But that one's really important. If you don't do that, okay, it's true. Yeah.
Thank you so much.
Then there are also models. I mentioned before about using different data representations, or Satya asked about it. I mean, there are acoustic features which you transposition variant, but then you open and you start training loads of information to these models. You don't have a lot of data to train them on, so we haven't really looked into that. So we're just relying on tonic normalized pitch curves for
now. Thank you so much for the presentation. It was really helpful.
Question.
I wanted to ask about my last question is about the learning itself. So what kind of loss function or medic function is being used for the learning?
So for the
contrastive or the embedding space, bringing things together and other parts.
It's a good question. So the embedding space is a model that we didn't develop, and I can't remember exactly what the loss conceptually it kind of creates like convolutions of the time TS direct. It creates convolutions of the time series inputs, and then it ensures that those convolutions are distance in the space. Sorry.
Thank you so much.
Well, thank you for the question. Maybe we have one more from Satya.
Yeah, it's not a question. It's just a small idea which I had regarding this annotation process, because I know it's going to be hard if you just go at it brute force. So one of the thoughts I had is, since we already know what the notes are in a raga, the ascending and the descending scales, maybe that can a a certain level of automation can be introduced to sort of guide the annotation process before it is sort of handed over to annotators to, I don't know if that's a useful idea, but, or sort of, since you already have some certain annotations for one or two ragas, maybe use the actual annotations combined with the scales, known scales to help annotate more performances in the same raga or something. This is just a general idea. I'm happy to discuss this because I also know UAS also works on annotation now, and you also. So maybe if you want to explore something in these directions, I'd be happy to talk. Yeah.
Well, I mean, all of the annotations that we have, I would only want to trust actual Carnatic musicians mostly with doing the annotations. Sometimes it's very obvious and someone else could do it. Sometimes it's really not so obvious. That's the problem. So we are talking about people who already know the kind of so-called scales of raga. Yeah, no, we had thought about, I mean, we do work with US, no, Tom?
Yeah, sorry.
He's involved in, he actually was involved in doing annotations on one of our first sets.
Okay.
And we did a process pretty much as you described. I kind of gave him a bit of tuition and guidance on it, and he did it, and then I did another check of it at the end. So I think something like that could work, but it still requires like me or someone with preferably even more knowledge doing the check at the end, because there's always going to be errors with someone who's not a Carnatic musician doing this. And even, amongst Carnatic musicians, as someone else there pointed out, mostly, yeah. So Svaras is a bit less controversial than maybe Sanchara, starts and ends, for example, which is, you're going to get a lot of variability even between experienced Carnatic performers. Svaras mostly should be a little bit more straightforward, but there's still, even between experienced annotators, there'll be differences, and we have to deal with that somehow.
I just to follow on from that about tools that automatically are doing it to assist. I think I talk about transcription. I think if we're being realistic, we're not going to solve problem of transcription. I mean, if certain annotators might disagree, then we've got no chance with the amount of data that we've got. But that's not to say we can create a tool that creates a valuable level of symbolic transcription that might be able to be passed to an expert annotator, as Lara mentioned. So, yeah. All right, should we wrap it up?
Yes, I think so. Yeah, it's 4 past, so yeah.
Yeah. Well, thank you very much, everybody. Thank you for coming, everybody online. Thanks, Lara. Pretty good presentation.
Thanks so much. Thanks, everyone. Thanks for your attention and nice questions.
All right. Speak to you, Lara. Bye.